While we're waiting for that, does anybody want to volunteer, either Carlisle or Montgomery, to go ahead and go first? Carlisle, you'd like to go first? Fantastic. I'm going to pull up your presentation. I'm going to turn off my video. Now, would you like me to turn your video on, or are you just going PowerPoint? Oops, I just clicked you off there. Sorry, Carlisle. Go ahead and you can get started with your PowerPoint. I will click the screens as you go.
I decided to do my project on the satellite. Turn to the next slide, please. Now, I decided to do my project on the satellite communications of the Deep Space Network. The Deep Space Network is a worldwide network created by NASA to receive communications from unmanned space vehicles that explore the solar system. The network works well, and because of the DSN, lots of data has been received about our solar system. However, there are some challenges in regards to receiving the data. The two main challenges are distance and power. Distance is a challenge because of the vast distance between the unmanned space vehicles and the receiver dishes of the DSN. It's hard to receive the signal. Power is a challenge because space vehicles must be lightweight to travel in space, and therefore they emit a low power frequency signal that is hard to pick up, like these. To combat these challenges, NASA has made sure that the receiving dishes in the network are very large and all precisely shaped. As you can see in this picture of one of the Deep Space Network dishes, the dish is curved into a shape referred to as a parabolic shape, so the signals can be caught easily and then gathered into the center of the dish to be picked up by the focal point called the focus in the center of the dish. To build a model of a satellite similar to those in the Deep Space Network. You can see how in the first picture I created a large parabolic shaped dish with a wide surface area, reflecting all the signals into the focus point. You can see in pictures 2 and 3 how the dish works by receiving the LED light and indicate how much light is received on the mirror located in front of the dish. My dish operates on the same principle that the DSN dishes that NASA operate on. I think the DSN network is a wonderful contribution to the exploration of space, and hopefully, as technology advances, we will continue to learn more about space and what is out there. Slide 6. Thank you for watching my presentation.
All right, great job, Carlisle. I love how you made the little model to go along with your project. It was definitely a very interesting and informative project. Now, some of you joined partway through the project, or excuse me, the presentation. Carlisle did a fantastic job. Does anybody want to make any comments or ask Carlisle any questions? I'm going to remind everyone that everyone worked on their projects very hard. If you are going to make a comment, please make sure it is a positive comment. And if you have a question, we'll see if Carlisle can answer it. And if not, maybe I'll have an answer, but I'm not sure about that. So, would anybody like to comment on Carlisle's presentation? All right. I see some of you guys are chiming in the text chat. Fantastic. All right. Does anybody want to volunteer to go next? Anyone want to volunteer to go next? Mohammed, awesome. Let me pull up your presentation. All right. Would you like your camera on, Mohammed, or would you just like your PowerPoint up? All right, I hit the camera on my end. If you want to turn your camera on, go ahead and click it on your end. I see it coming through. All right, Mohammed, here we go.
Today, we're learning a story about the sun. Next. Look, the sun sends out light all the time. The sun's light, solar energy. Most of the sun's energy goes into space. Solar energy goes into Earth. If we couldn't love on the sun, without the sun, we couldn't live on Earth. Be too cold. People and animals and plants can live on Earth because it's the right temperature. Thank you, everybody. I'm South Africa. Bye from South Africa.
All right, great job, Mohammed. Thank you very much for sharing your facts about the sun with us. Fantastic job, and I love how you did your presentation and came up with the facts. Good job. Do we have a volunteer to go next? Anyone? All right. Anyone? Okay, Victoria is to go next. I'm going to turn her camera on. And go ahead, Victoria. I see you coming through. There you go.
Hear me? I don't know. Never mind. But I actually drew in an astronomy book that I made myself, where I drew and I did a whole bunch of stuff in it, So that's what I wanted to show you today, and that's where I got and there's a lot of learning stuff that I thought that the class could know about because this I researched on my own. So the first page is a picture of, sorry, it's in gel pens and pens, but it's supposed to be of, here is the Earth's atmosphere, and a person is looking out into, well, outside of the atmosphere, and they are just seeing the crazy witchcraft of space, kind of. So that's what that was of, and I have, where I told you guys about the moons, I actually did my own set of moons with blood moon, because it was actually last year I did the moons. Trying to figure out the camera so you can see it, but right there's blood moon. So that's there. And I know this was something we didn't talk about here in this class, but the celestial dome with the celestial pole and stuff like that, where it's an imaginary dome and it's half of a globe. This sky model includes the zenith right here, and which is the point on the celestial directly above your head, and the nadir, which is the point directly below your feet. So there's my little person, and so there's also includes the I don't know how to say it, but it's up here, and there's the horizon, and the north, south, east, and west, and so yeah, and there's one last thing I would like to show you, which is these star paths that I looked up, and it's not the best picture of it, but I tried to make my picture as close as I could because there's millions of stars. So this is when it's looking north, and here is the Polaris, or the North Star. So they seem to be going in a circle in a counterclockwise motion. And south, which is gently curving and arcing. And they are now going clockwise. And east, when looking at east, it looks like the stars are gently curving and arc to the north and south. And for west, when looking west, you see the stars trails setting to the earth and arcing. I've also made more pages of it, but that's all I would like to share, and hopefully I gave you some information on some stuff you didn't know. Bye.
Great job, Victoria. Thank you so much for sharing that. That is an awesome feat to have created a book like that. I am very, very impressed. And thank you for sharing it. I love the moon phase idea that you shared with us and that you showed in your book. So thumbs up for that. And let's see, I do have a couple of more projects. I have Monty's. Monty, I'm not sure if you can talk. Your microphone looks like it might be crossed out. But Monty, would you like, no, maybe not. Would you like to go ahead and share with us, Monty? Or would you like me to read yours? All right, then I'm going to go ahead and read it. Monty did a project on solar weather and fireballs. So here we go. Hello, my name is Monty, and I am going to tell you about solar weather. A great resource for learning about space weather is at spaceweather.com. Here, you can take a look at the current weather conditions in space, such as solar wind, X-ray solar flares, the radio sun, the number of sunspots, and the number of sun-spotless days. You can also learn about where the current auroras are, currently in an oval shape, the interplanetary magnetic field, noctilucent clouds, coronal holes, current fireballs, and just so much more. Today, I will talk about fireballs. Fireballs' orbits intersect at Earth at a single point. If you look at the diagram of the inner solar system, the orbits are color-coded by velocity. It's a little hard to see here. The fast velocity is blue, and the slow velocity is red. The terminology for a fireball is that it is a very bright meteor. It is brighter at the same magnitude of the planet Venus, -4 magnitude. A fireball which explodes in a bright flash at its end is known as a bolide. There are usually visible fragments. The brighter the fireball, the more rare it is to see it. While several thousand fireballs occur every day, they usually occur most often over uninhabited regions and oceans. While you can see fireballs in the daytime sky, only those who are a -6 magnitude or brighter can be noticed in parts of the sky away from the sun. They must be even brighter if they occur closer to the sun. Fireballs also leave two types of trails behind them. The first type of trail is a glowing trail of excited and ionized air molecules, which are left behind after the passage of the fireball. They only last a few seconds, but rarely last for several minutes. These types occur in altitudes higher than 80 kilometers, or 65 miles, and are associated as fast meteors. These types are spotted at night and rarely by day. The second type of trail is a smoke trail, which has often seen fireballs spotted in the daylight. These types occur below 80 kilometers and are non-luminous. Their trails look similar to those left behind by aircraft. They can be either light or dark in appearance. An interesting note: an experienced observer might expect to see one fireball of a -6 magnitude or better for every 200 hours of observation. A -4 magnitude fireball can be observed once every 20 hours. Now that I've told you a little bit about fireballs, I encourage you to go outside and try to find some. If you do spot a one or more, you can report it to the American Meteor Society, as they collect fireball reports. And then he has the resources that he used. Great job, Monty. I was very impressed with your fireball research. You did a fantastic job. Okay, so I think that is all the presentations that I have today. So what we are going to do is we're going to talk about two neat, in my opinion, things. Sort of fun solar system or space science research. The first thing that we're going to talk about is black holes. Something we really didn't get a chance to talk about in our class. So if you look up on your PowerPoint screen right now, you should see a picture of a black hole. Does anyone want to go ahead? Oh, here's a second picture. Here is a picture from a telescope of a black hole. Now the black hole is actually the center part here that is black. Here is another image of a black hole from the side. And here you can't actually see the black down in the middle. Would anyone like to read this slide about black holes for me? Go ahead, Victoria.
So, black holes. The intense gravitational field left when a giant star collapses. I love black holes. It is called a black hole because not even light can escape.
Good job. Black holes, their gravity is so strong that even the light from stars, from other objects, cannot escape that pull. Here are two pictures where we can compare a black hole and a neutron star. Both look very similar. They are circular in shape. However, the center of the black hole is, you guessed it, the color black. And the center of the neutron star shows a very bright color. Here's another image of a black hole. The black hole is the black section in the middle. The outer edge of a black hole is called a photon sphere. The photon sphere is the outer edge where light bends, but still escapes. The event horizon is part of a black hole, and it's the point at which no light can escape anymore. And a singularity is a shrunken star in the black hole that is too small to be measured, but it does have an indefinite density. So here's the different parts of the black hole that we just talked about. The photon sphere is along the outer edge. The horizon is a circular spot in the middle. And in the very center of your black hole is the singularity. That's a little brief glimpse of a black hole. And next we have galaxies. A galaxy is a large assembly of stars and nebula. Here is a picture of a group of galaxies. Our Milky Way is a galaxy, or the Milky Way. It's a flat disk with spiral arms. If you look at this image, you can see 6 different spiral arms. There's a yellow spot towards the bottom center, and that is our sun. And then you can see the other arms. The Cypress arm, the Perseus arm, the Orion arm, the Sagittarian arm, the Saturn Rex arm, and the Nerma arm. There are 3 types of galaxies. Does anyone know the 3 types? Or any of the 3 types? No? All right, well, let's take a look. The first is elliptical. Elliptical is very much shaped like it says. It's an oval. And it is the most common type of galaxy. It contains very little gas and dust, and most are very dim and difficult to see. Here is an image of an elliptical galaxy. Spiral, like Sophie said. The second type is a spiral galaxy. A spiral galaxy has a dense center with spiral arms. They are bright and very easy to see. They contain large amounts of gas and dust and always are producing new stars. Here is a picture of a spiral galaxy. And another picture. Yes, Victoria. And then there is irregular galaxies. Irregular galaxies have no specific shape. They contain large amounts of gas and dust, and they are very small and faint, and therefore pretty hard to see. And here is a picture of an irregular galaxy. Another space term you may have heard that we didn't really get a chance to talk about in this class are quasars. They are small, powerful sources of energy thought to be cores of distant spiral galaxies. They emit radio waves and very bright light. And here's 2 pictures of quasars. And there we go. Now, something that I'm guessing most of you have thought of at some point is maybe being an astronaut. Go ahead and give me a little smile face if you have ever thought maybe in your future you would want to be an astronaut or involved with NASA in some way, shape, or form. All right, I figured I'd get some smiles with that one. Okay, so what we're going to do now, and how I like to sort of tie up my learning labs, is we're going to think about and look at what it takes to be an astronaut. So let's go to our whiteboards. And first, we are going to go, what does it take to be an astronaut? Does anyone have any ideas? If you do, go ahead and write them right up here or write them in the text chat and I'll move them over. But what do you think it takes to be an astronaut? As you're thinking, I'm going to give you a little bit of background information about what astronauts are, what they do, and how NASA has found them in the past. So space exploration really got going in the U.S. in 1961 with the first U.S. manned spaceflight. In 1959, NASA asked the military to list members who met specific qualifications. They were seeking their first astronauts. NASA required jet craft flight experience. They wanted pilots. They wanted engineering training. These first astronauts needed to be short. They could not be more than 5 feet 11 inches because of the limited space in the space capsule Mercury that was being built. After lots of intense screening, both physically and psychologically, NASA selected 7 men from the original pool of 500 candidates. Those 7 men were Captain Gordon Cooper Jr., Virgil Grissom, Donald Slayton, Lieutenant Colonel John Glenn, Navy Lieutenant Scott Carpenter, Navy Lieutenant Walter Schirra, and Alan Shepard. Those were the first 7 astronauts for the United States. They were chosen because they were both physically and mentally fit, and they had flight experience and engineering experience. So let's see what you guys put as to what does it take to be an astronaut. And up on our whiteboard we have training. Great job. It certainly does take lots of training. A knowledge of space. Experience. You must get used to gravity. Some people have trained in pools. Great job. Those are all great qualifications. A few that aren't up here that I would like to add are mental awareness and physical fitness. Astronauts need to be able to adjust to their surroundings. So if something goes wrong in space, they need to have the mental ability and the physical ability to fix whatever is going on. So, since the first group of astronauts, scientists, or NASA, has sort of switched the need to be a pilot to the need to be scientifically smart. Okay, they want someone who is able to problem solve. Here are a couple of images of some astronauts at work. Now, it may not be, or they may not be doing what you would first think of as an astronaut. The woman astronaut, who is in the blue suit, she is studying and taking notes. And if you look closely, there are two astronauts right here, 1, 2, with American flags on their suits. And then the third astronaut has a Japanese flag on his suit. In order to be a NASA astronaut, you need to be a U.S. citizen. However, NASA does have programs with other countries where we will put their astronauts or cosmonauts, they're called different things in different countries, up in space with the United States astronauts. So if you decide you want to become an astronaut, you need to be smart, physically fit, and a U.S. citizen. Did someone just beep with a question? Okay, the astronaut on the left, the man that looks like he has sort of goggles on or cups on his eyes, something's going on over there, is training. Astronauts train lots of hours before they are allowed up in space. And most astronauts don't even end up in space. Most of them end up doing on-the-ground training and on-the-ground problem solving for NASA. The technical requirements as of today to be an astronaut are that you need to have a bachelor's degree in engineering, science, or mathematics, followed by 3 years of either pilot training or 1,000 hours of pilot training. If you don't have the pilot training, you can substitute it for a doctorate degree in certain sciences and math. You also need to pass long-duration flight physical, which means you need to have 20/20 vision, you need to have good blood pressure, and you need to be between 62 and 75 inches tall. If you go to NASA's website and you look at what they recommend you do in college, they recommend that you do a science or engineering degree with a specialization in space. Now, I was looking around there the other day to see if they suggested certain programs, and they said right on there that they do not have certain colleges that recommend, but that they do recommend, and you do need to attend a 4-year college. Okay, once you get picked, if you're so lucky to be an astronaut, you go to at least 2 years of training where you are part of the Astronaut Candidate Training Program. During that time, you will learn how to fly a jet if you do not know how to fly a jet. You will complete military water survival. You become scuba certified. Anyone know why they might have you become scuba certified? Why, Victoria? Why do you think?
Maybe because, since, well, for one, the air is different in space because of the gravity, mostly for gravity purposes, because let's say you're really deep in space, well, deep in underwater, like you're scubaing, you need to be able to handle the breathing, like, that's on your lungs, and have to learn to get that breathing down. because the gravity is it is very similar in very deep water into space. So that's what I think, at least.
All right, very nice. I would agree that it definitely is so that they can learn how to breathe with that different type of air, with pressurized air. And it also is just a different feeling. Good job in the text chat, Mohammed and G, adding in your thoughts. So great job. Astronauts also need to be able to withstand hyperbaric, which is high pressure, and hypobaric, which is low pressure training in altitude chambers. Practice what would happen if something happened on the spacecraft and either they lost pressure or the pressure became too great. And a big part of the astronaut training is for astronauts to learn how to deal with emergencies. Emergencies as large as a hole in a spacesuit, and emergencies as small as something just leaking or not working correctly, because any emergency tends to be a large emergency when you are in space. The pay and benefits, astronauts get paid anywhere between $63,000 and $120,000 based on how long you have been an astronaut. And the future of becoming an astronaut seems to be focused on the science behind being an astronaut, as well as being able to perform other types of experiments in space. NASA is also working on sending scientists and astronauts to different parts of space and different planets. So they have a little disclaimer on there that their requirements for being an astronaut are ever changing with their needs. So I thought that was pretty interesting about what it actually takes to be an astronaut. Now, unfortunately, we are in our last day of our Solar System Learning Lab. It's been a great class. We've done some fun things, some different things, some hands-on things in the beginning of the class, where we built our little craters, where we made them with the cocoa powder and the flour. And we've done some PowerPoints, some presentations that you guys have done. What I would like to do is I would like to take a minute and have you guys help me make this a better class. So what I would like you to do is, in this first square, write your favorite parts of this class. And in this second square, I would like you to list your least favorite parts on the whiteboard. Please keep in mind that I cannot see what you write up here, so please be honest. All right, just take a minute and add up here any likes or dislikes. All right, I'm just going to give you one more minute to fill this out. I really appreciate it. All right, thank you guys very much. I went ahead and took a picture of what was up here so that we can use that when we are planning future learning labs. So thank you for taking the time. So this is what's going to happen now that we're at the end of class. I am going to go back through Moodle, make sure I didn't miss any assignments that you guys turned in. And if I did, I'm going to grade them. I'm going to give you guys grades for today's projects that you did. Then you are going to get an email from me asking you to asking your parents to complete a short survey and send it in to me. The survey is completely anonymous. Then you are going to get a link to print out a certificate. You are eligible for a certificate if you have attended 60% of our classes. So if you've come to more than half of our classes, you get a certificate that will say you have completed the Solar System Learning Lab. You can go ahead and print it off, and you can go ahead and send it or file it with all of your school information. So that's the end of the housekeeping for this class. Now, sort of the last topic I was going to talk about is commercial space flights. Has anybody heard of people like you and me buying a ticket to go into space from a company called Virgin? I think it's Virgin Atlantic, but Virgin? The space company Virgin is doing commercial space flights. The commercial space flights are for people to buy tickets. You go up with a trained astronaut, and you go into just out of the Earth's atmosphere into space for different periods of time where you become weightless. You can do little flips around or whatever you want, get back in your little seatbelt, and you come back to land. Now, they are doing those out of the U.S. This company, Virgin, also has contracts with the U.S. government and NASA to do experiments up in space. So I thought that was kind of a neat little tidbit. It's a way for you or I, if we win the lottery and end up with tons of money, to go ahead and go to outer space. Unfortunately, they are very expensive. When I was looking them up, they actually don't even list the price on their website. That is how expensive it is. But the neat thing that Virgin is doing is they are allowing everyday scientists or universities to go and send their experiments up in space and allow them to be completed in space, which will be very useful for researchers. Right now, it is very hard to get room on a NASA mission for a lot of universities, so this will allow a lot more space exploration. And who knows, maybe in the near future, one of us will be in space because it won't be as much of an expense. Or maybe you, one of you, will be the next astronaut blasting off to the moon or to a planet. I hope that that is true. Does anyone else have any fun facts about the solar system or space that they'd like to share with us? If you do, we'll go ahead and do that. If not, we're going to go ahead and sort of play Review Jeopardy. So if you have something you'd like to share, go ahead and raise your hand. Go ahead, Victoria.
While you were reviewing black holes, because black holes are probably my favorite thing about space, they just excite me so much. But one thing is that I was always talking to my dad about this, and I was always like, but what if you get through a black hole? What if there's something outside of that? Anyway, getting to my point is that what he said is that nothing can make it through no one has made it through a black hole. Well, black holes, when you go in them, you become flat. So it pretty much, it wouldn't work. And my dad kept saying, no one would be able to do that. But, that's just what I wanted to share, that apparently there's no other parallel universe that we know of, and if you went into a black hole, you would be squished.
Yes, your dad is right. As far as I know, well, let me rephrase that. As far as I know, I agree with your dad, Victoria. All right, if no one has anything else they want to share, we're going to go ahead and we are going to do our solar system trivia to review what we've done this year. So we're going to go back to our whiteboards like we have done before. Or not our whiteboards, I'm sorry, our notepads like we have done before. So your notepad is listed where your math is, but it is the second icon that looks like a little yellow notebook. And it says noteboard. I'm going to add the first note. First one to answer it gets 2 points. Every other correct answer gets 1 point. So go ahead. Question 1 is, what is the third planet from the sun? Go ahead and type it on the noteboard, not in the text chat. All right, I see correct answers from Victoria, Carlisle, Sophie, and Victoria, you were first, so you got 2 points. All right, next question. They're going to get harder. What is the name of a dwarf planet? And Mohammed, you got the last one as well. What is the name of a dwarf planet? I see. Victoria, you have the correct answer and were first. Sophie, you have the correct answer. Carlisle, you have a correct answer. Mohammed, you have a correct answer. Great job. There were a few answers there. The two that you guys put were Charon and Pluto. Next question. What is the Earth's evil twin planet? I like the I have no ideas. Evil twin. Earth's evil twin. It's the nickname of a planet. The correct answer is Carlisle. You got it first. Venus. All right, next question. What is an area of no light in space? What is an area of no light in space called? Hint, we did this today. An area of no light. Perfect. I see some right answers coming up. Good job. The correct answer is a black hole. And our last question. Let me think of a good one. Last question. Last question is, what is the closest planet to the sun? And the closest planet to the sun, Victoria, you got it correct. You were the first one. The correct answer is Mercury. And on that note, we are going to end class. The winner of that round of Solar System Jeopardy was Victoria. Good job. I hope you all have a fantastic day and enjoyed this learning lab. You should get an email with that survey in it at some point today. If you could just take a minute to have your parents fill it out, that would be great. I would really appreciate it, as would the rest of the Bridgeway staff. If you have any questions about that or about any other learning labs, we are offering some learning labs this summer. I believe there will be a robotics learning lab and a bridge building learning lab. And then we will be offering some new learning labs for next fall. I hope you guys have a fantastic day and enjoyed this class.